Is it working? Is it working? Is it working? There we go. Excellent. All right. So, hello everyone and welcome. This is Code Soul, and today we're going to go over an introduction to MongoDB. I am running on 3 hours of sleep because I suck at life, but going to do our best. And fortunately, I'm very familiar with it, so it shouldn't be too difficult to cover things. For those of you who have not been here before, I'll introduce myself in a second, but you can join our Discord here. It's a great place to ask questions if you have them. We also have like a job posting board and career help and all this kind of stuff. So you can do that. It's not always active. Usually if someone posts a problem, then everyone jumps on and is like, yo, I want to help with the problem. But it is worth joining, especially because we share announcements and all that kind of stuff on there. And then in terms of how we do these kind of workshops, let me get this sign in here. Actually, no, screw it. We'll do it at the end. Right. So don't be afraid to interrupt me and ask questions. I will repeat questions for the benefit of the stream, because if you have a question, chances are someone in the future will have the same question, and having it recorded is helpful. If I speak too quickly or if something doesn't make sense, please interrupt me and tell me, like, Beege, that made 0 sense, please try again. I can do that, no problem. Basically, the big thing is, if what we're talking about today does not make sense to you, we have wasted time, and I do not want to waste time. So if anything's not cool, then just let me know. But enough housekeeping stuff. Let's get started. So first off, a quick disclaimer. I am not an expert in this. I have not written a book on this. I use it every day when I was a backend engineer, and it's been a little while since I've done that, but I still work with MongoDB quite frequently. So basically, this is like, not everything is 100% accurate all the time. Things change, all this kind of stuff, but this is accurate to the best of my knowledge. Always check stuff, always check documentation, because life is chaos and changes frequently. And then, wait a second, did I skip? Yeah, I skipped a slide. So who the hell am I? Why am I up front here talking to you guys? So I'm Beege, if I haven't met you before. Right now I work as a product manager, going to be a technical program manager soon because title changes and role responsibilities and all that. But my background is more in backend engineering, DevOps. I've done data analysis, I've done data engineering. SQL databases are my jam. I can make them do silly things. But I ended up learning about Mongo for the company I'm actually currently at for a couple of the applications we use, and I ended up finding them really cool, so I thought I would check if people wanted to learn about it, and the feedback was, yes, we want to learn MongoDB, so here we are. Let's dive into what we are going to cover today. First, we're going to go over what is a NoSQL database as compared to a SQL database. And then we'll get into what is MongoDB specifically. Then we'll go over when should you use MongoDB, right? Because you want to use the right tool for the right job. Then we'll dive into using MongoDB. We'll go over the structure and kind of the hierarchy of entities in MongoDB. We'll also go over querying. How do you work with data in MongoDB? And then we'll kind of go over the kind of common stuff between MongoDB and SQL that we won't go in detail here today. I'm assuming that you have at least a little bit of SQL knowledge. If not, feel free to stop me and ask questions. That is okay. But to be perfectly honest, I threw this together in a hurry, so I wasn't able to kind of recap all of the SQL stuff. Then we'll have the hands-on session where I actually have a NodeJS application, a very bare-bones NodeJS application, and a Docker Compose setup to set up a MongoDB database. And we'll use that to put some data in, experiment with things, go over data modeling, these kinds of things. And then we will end with going over data modeling in MongoDB. Personally, I believe that is the most important part, because if you come from a SQL background, MongoDB is going to be very confusing, and there are things that are really hammered into you in a SQL world that MongoDB is like, nope, we don't do that. And you're like, why? What's wrong? So we'll go over that stuff. So any questions about the agenda today before we move forward? Also, for the people who haven't been here before, when I ask if there are questions, I wait for an uncomfortably long amount of time. That is on purpose because people need time to think about, okay, do I actually have a question about this? Okay, how do I phrase the question? Oh God, I need to actually ask the question. So I give you time to go through that process, okay? So given that there seem to be no questions, let's go ahead and get started. So what are NoSQL databases? NoSQL is short for not only SQL, or at least that's what they say. And basically, it's databases that are not your traditional relational database. You don't have tables that you normalize out and then set up relationships between. You don't have these kind of foreign keys and integrity checks and all this kind of stuff. You may have different types of integrity checks. But it's basically not MySQL, Oracle, Postgres, these kinds of things. Now, a lot of the SQL databases have started adopting NoSQL features. For example, MySQL and Postgres do have a JSON column type that you can use, which is basically like MongoDB, but that's out of scope for this. And there are various types of NoSQL databases. Because it's kind of an exclusionary category, it covers a lot. Because anything that's not a SQL database, but that is a database, is a NoSQL database. So technically, a CSV file is a NoSQL database. Now, if you say that to a data engineer, they'll hit you over the head. But just to kind of demonstrate the definition here. So there are different types of NoSQL databases. There are document stores, which is what we'll focus on today. These are usually JSON documents. There's also key value stores. This is common with systems like Redis, if you have heard of that one. There are graph databases like Neo4j. They're very useful for things like social networks. And also for like, there's a lot of kind of semantic graph databases for like language stuff. There's time series databases like InfluxDB, or technically like Splunk. If you need to track data over time, Prometheus is technically also a time series database if you do monitoring stuff. And then there are columnar databases, which are very popular for analytics. These are things like HP Vertica, MySQL, and well, actually I don't exactly recall about MySQL, but I'm quite sure Postgres also has a columnar engine. That's usually for, you know, where you're only doing aggregations. But we're not going to go over all the different types of things today. We're only going to focus on MongoDB. And basically, the purpose, the reason NoSQL databases were built are twofold. It's mostly for scaling and for specialized use cases. We had SQL databases for something like 30 or 40 years before NoSQL databases started becoming popular. And that was because SQL databases are really, really well designed to fit a very large number of use cases. And so for your typical application, a SQL database is good enough. But the problem with SQL databases is that they don't handle distribution very well. There are things you can do to do distribution, but there's a limit to it. So if you're doing global scale stuff, SQL databases run into issues. And that's where NoSQL databases come in. Additionally, SQL databases do have very good performance, even when doing complex joins or complex aggregations, but there's still a limit. Whereas the SQL databases can get very, very, very fast response times, especially MongoDB, depending on how you design the data, and we'll talk about that later in this presentation. And then there are also specialized use cases like graph databases or columnar databases where a normal relational model just doesn't make sense for those kind of usages. Okay, so does that kind of make sense so far about the broader categorization of NoSQL databases? Cool. All right, so we're gonna, I promise we're not gonna spend too much time on all the theory, okay? But getting into what is MongoDB. So it is a JSON document store. Out of all that list, it's the document one, okay? Another big thing is MongoDB is scalable. It scales like crazy, and it scales in multiple ways. Additionally, it is based on BSON, which is kind of binary structured object notation. It's basically the same as JSON, except it supports binary data types and not just text. Because it's not serialization, it's data storage. And because JSON was designed for serialization, so it has to be read by humans, but BSON, no, you're going to have something else that renders the BSON for you, so it can be stored in binary, and we'll talk about that a little bit later. Also, it's optionally distributed. You can just run a single instance, and that's fine. Or you can do a cluster, and you can distribute reads and writes across the cluster. And there's all different ways to configure that. We'll only touch on that part briefly, because that's a little bit more advanced. And you can run it on-premise, like we're going to do here. I could just run it on this notebook. Or there is MongoDB as a service. It's called MongoDB Atlas. We actually use it at Lunit for just a couple of our smaller tools. But it works really nicely if you don't want to worry about managing the infrastructure, managing replication, all these kinds of things. So that's MongoDB at the highest level. There's way more details that we'll get into, but does this make sense so far? Cool. All right. So, when should you use MongoDB? That first bullet point is the most important, okay? If you forget everything else in this presentation and you remember that first line, we did good, okay? A lot of people think, oh, MongoDB, it has a flexible schema. So if I don't really know how my data is, I can just use MongoDB and everything is okay. No. No, 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 no. That is the fastest path to hating your life. How do I know this? Because I went down that path and it sucked, okay? You want to use MongoDB when you know your access pattern, okay? What do I mean by access pattern? You use MongoDB when you know how you're going to read your data, okay? This is the first and biggest difference with SQL databases, okay? With SQL databases, when you're building your application, you can start at the database layer. And you can say, what are my entities? Okay, I'm going to have an employee. I'm going to have a department. I'm going to have like a division, right? You can establish your hierarchies. You can establish your relationships without actually knowing exactly how the application is going to use the data, right? You need to have some idea, obviously, but you don't need to know all the little details. You don't know how every query is going to work, because SQL databases are intended to be flexible and fulfill multiple use cases. They were designed to do that, and that is why they lasted for 30 or 40 years before new applications needed to be developed for serving data. MongoDB does not work like that, okay? And that'll be more evident when we get to the data modeling part, okay? But if you don't know how you're going to show the data to your users, how you're going to read the data, how you're going to write the data, then don't do anything in MongoDB yet. You need to figure out how you're going to use your data before you start storing it in MongoDB, okay? That is the most important thing I want you guys to understand when you leave here, okay? Figure out your data, how you're going to use your data first, and then you can throw the data in MongoDB, okay? So basically, plan stuff. And then in terms of like the other stuff you should check, MongoDB is best when you write data once and you read it many times, okay? You can absolutely update data in MongoDB, but when you do multiple updates to the same document, it ends up being a lot of work. Now, that is okay. There are times where the cost of that extra work is totally worth it. That's fine, but be prepared for that. If you need to write many times to the same document, or rather, if you need to write the same data many times or update the same data many times, it can end up creating a lot of work for you, okay? And that's going to make more sense as we get farther in the presentation. Also, if you have very few relationships, okay? So if you have like a very deep hierarchy of data, MongoDB may not be the best solution for you, okay? Now, not in all cases, because you're going to find it depends with everything. But if your data relies on a lot of relationships, maybe MongoDB is not the way to go. You can do relationships in MongoDB, and there are ways to manage relationships in a manner that works well for the MongoDB engine, and we'll talk about that in a bit. But if relationships are the core part of your application, rethink things. Also, if you need super high speed, MongoDB is fast, especially for reads. It's super fast. It is crazy fast if you model your data correctly, if you know your access patterns to model your data correctly, okay? Also, if you need to distribute your data widely, MongoDB is good at that. But when you do more distribution, you end up running into eventual consistency issues, because you make a change on this node, it may take time to propagate to other nodes, okay? There are ways to manage that, but that's more of an advanced thing that we're not going to cover in detail here. We'll just touch on it lightly. And then if you need high scale, okay, because of the distribution. I probably said scale before, I probably should have said scale before distribution because these things are connected, but yeah. So these are the kind of the best use cases for MongoDB, okay? Or, I probably should have put this in the presentation. We actually have a use case for a new application we're building now where the data in and the data out should be in JSON format. So MongoDB makes sense because it stores JSON. But we still need to be able to query it like a database. So that's another use case. I'm sorry I didn't put it in here, but I'll add it later. Okay? So does that all make sense for kind of when you should consider MongoDB as an option? Excellent question. So for the benefit of the stream, the question was, how does MongoDB scale? Is it vertical or is it horizontal? And if you're not familiar, vertical scaling is you get a bigger server. Horizontal scaling is you add more servers. MongoDB scales horizontally very well. And there are different ways to do the horizontal scaling. MongoDB supports sharding and replication. And it supports both together. And we'll touch on that a little bit more later. But you know, if you do both, your infrastructure costs are going to go up a lot. And when you have sharding, when you have replication, you end up having eventual consistency issues, but MongoDB has controls around that too. Again, that's a little bit more of an advanced thing. But yes, it relies mostly on horizontal scaling. And also, if something supports horizontal scaling, it also supports vertical scaling, but the point is to avoid vertical scaling because you don't want to incur downtime. Adding more servers doesn't require downtime. Taking down a server to make it bigger requires downtime. So, yeah, but it does support horizontal scaling. Okay, does that make sense? Cool. Other questions? Yes.
What are some examples, like you mentioned, in case of relations like division, employees, this kind? So that can be fit for, let's say, a school or something. So what situation falls under these points?
Got you. So the question was, when we talk about applications that have few relationships, you know, I said the example of like an HR system where you have like employee, team, department, division, whatever. So it can support like that hierarchical structure. It's just a little bit more difficult, or maybe not more difficult. It just requires more effort. But things where it very clearly does not fit, like social networks, don't use MongoDB for a social network, right? That's not a good idea, because the key thing of a social network is the relationships between the people in the social network, right? Or something like a movies database, right? That's a very common example for a graph database, because movies, you care about the movie and all the actors in that movie and which other movies the actor has been in and the director and which times the director and the actor have worked together, right? That's all very relationship focused. Maybe not great for MongoDB. Now, you can do it, and you can probably make it work pretty well, but it might be more easily done with a different solution, okay? Does that kind of answer your question? Or?
What kind of example, like application specifically focusing these aspects? Like what applications is it good for?
Okay, so the question was, in that case, then what applications is MongoDB good for? A lot. Let's see. So, e-commerce. MongoDB is very good for e-commerce. When you look at a lot of the MongoDB kind of documentation stuff, you'll see that e-commerce is quite an example that appears quite often. Something like event management, it's very good for. Something where you need a flexibly consistent structure, which sounds a little bit confusing. But it'll make sense when we get into the data modeling side of things. MongoDB is particularly good at that, because with with SQL systems, right, you can have like a bunch of null columns, but then that makes stuff a little bit messy. Now, in terms of performance, it doesn't affect you too much, but people just don't like it. It makes it feel like wasteful. You have to like define a whole bunch of null fields, and then like it's difficult to see if your tables get really wide. But with something like MongoDB, if you don't have data, leave it null. Whatever, right? So there are, oh, sorry, 1 second here. Oh no, okay. What are other, right, oh, I haven't thought through this one deeply, but one thought that comes to mind very quickly is something like banking, because you never really update a transaction, right? The transaction happens, you write it, and then it's done, right? So that would, at a first thought, banking makes great sense for something like MongoDB, because it's write once, read many, because untied. Yeah, I would need time to think through more examples, but yeah, does that kind of answer your question? Cool.
So in case of event management, like one event may have some attributes, but it may not specifically be related to another event. So in that case, there are less relations and may be suitable use case in that sense.
Yes, exactly. So the thing you wanted to check was, you know, using the event management example, maybe there's a case where some events have some kind of data and other events don't have that kind of data, but they're all still events. Is that a good use case? Yes, absolutely. Because that goes, I mentioned earlier, kind of the consistently flexible. Like, it can be flexible between the types of events, but the data is still consistent for certain subtypes of events, right? And we'll talk about that example a little bit when we get to the data modeling side, but yeah. All right, cool. Any other questions before we move forward? Cool. All right. So, there we go. Now we got the right application in focus. So, real quick, let's go over kind of the structure of MongoDB. How is MongoDB organized? Now, I've kind of mixed the physical and the logical here, which is maybe not the greatest way to do things, but I threw this together in like 2 hours. So, MongoDB, when you set it up as a cluster, even if it's just a single node, okay? And you can optionally shard your data, basically say, hey, this data goes to this server, this data goes to that server, this data goes to that server, and that can help performance, okay? You can also do replication, so you can have multiple copies of your data for redundancy, okay? So if a node goes down, you don't care, there's a copy elsewhere. And that way you can avoid downtime. And then there's an instance within the cluster, right? Like an individual server within the cluster that is physically storing the data. But the shards, replicas, and instances, that's kind of all the infrastructure layer of things. If you are not administering and managing the cluster, you don't need to worry about that. If you're just a user of MongoDB, you can just forget that stuff, okay? And then there are collections, okay? Collections you can think of roughly like a table, okay? A collection should have documents of a similar structure and of a similar purpose, okay? And then you have the document, which is just a JSON blob, okay? So going back to like an HR example, right? You might have an employees collection, and each document in that employees collection would have data about one employee, okay? Does that make sense so far? Cool. Now, if you are considering using MongoDB for a very large scale, a very high availability application, you will want to learn more about shards and replicas, but that is more advanced stuff that we're not going to cover today. If you are just going to be an engineer who just needs to query a Mongo database, you can just not worry about it, okay? All good? All right. So, what about querying MongoDB? How do you get data in and out of MongoDB? So there are various types of operations. We have find, insert, update, delete, and pipelines. Now this may sound very similar to SQL. You know, for SQL you have select, insert, update, delete. And you don't have something like pipelines, right? So I'm going to explain each of these in some amount of detail. But as kind of a summary level, insert, update, delete, those are the same. They do exactly what you would expect to do. Insert puts data in, update edits data, delete removes data. Very simple. Find is like a select, except MongoDB, as you'll see in this other aspects bit here, is much more filtering focused than kind of field focused, okay? Because usually you care more about getting the right data out, and then you can worry about formatting it later, right? So instead of doing like, in SQL, you have your select statement, and you start with the columns you want, and then you figure out how to get it. With MongoDB, it's the other way around. How do you get the data first, and then you format it the way you want it to be displayed, okay? And then in terms of displaying the data, instead of selecting columns, we have something called projections, okay? And projections are when you tell MongoDB what format you want to output the data in. So do you want to rename a field? Do you want to combine fields? Do you want to concatenate fields? This kind of thing. These are projections, okay? And projections are used in the projections are used in the find and pipelines operations, and we'll talk about that in a little bit more detail in a bit, okay? But pipelines are when you need kind of multi-stage operations, and pipelines can be done for both find operations and update operations. And pipelines are mostly used for aggregation. So if you need to do grouping or counting or like windowing or any kind of like where you need to take many documents and combine them or split them or bucket them or whatever, you want to use a pipeline, okay? And we'll talk about that in more detail in a second. But at a high level, do these operations make sense in terms of what they're used for? Cool. All right, so let's talk about find. And real quick, I want to apologize. This slide is mostly empty. Usually I put fun images to kind of make things more fun and comfortable, but I'm running on 3 hours of sleep and I threw this together in 2 hours. So I'm sorry, guys. It's been a really rough week. But as mentioned before, find is very filter focused. So if you were to compare this to SQL, find starts with the where clause of a SQL query, okay? So you first develop your criteria for what data you want to retrieve. So you'll say, I need this field to have this value, or this field to have one of these values, or this field to not have that value, or this field to match this regular expression, okay? These are all different operations you can do in a find. And you can do it with many fields, and you can do like and, or, nesting, and exclusion, and all this kind of stuff. And it's complicated. I'll show you a couple of the operations in just a second. Also, it is JSON based. When you define your filters, it's just JSON. So if you want to find a document where name is Beege, you do curly bracket, name, colon, quote, Beege, end quote, close curly bracket. That's your find filter. Very simple, very easy to understand. So real quick, let me pull up the query operators here. There are a bunch of different query operators. Normally, I would pick out a couple of the like most common ones, but they're pretty intuitive. So for example, equals is useful when you're not doing just a simple this field is this value. Maybe you have some kind of calculation that you need to do first, and then you'll use the equal operator. Greater than equal to, in if it needs to match one of a group, less than equal to, all these kinds of things. A lot of them are quite simple, but you also get some more advanced ones. So for example, you can search with regular expressions, which is great, super useful. You can also do array operations. This stuff is really cool, really useful, and a bit hard to wrap your head around at the beginning. If you need to do array operations, think about it a little bit. When we get to the hands-on portion, I'll demonstrate some of the array stuff in more detail. And then there's also projection stuff, but honestly, the operators are not too complicated. It's just there's a lot of them, except for the array stuff. The array stuff is complicated. But yeah, does that make sense so far? Cool. I don't expect any surprises on this bit. And then, I mentioned earlier projections. Projections are basically like the select clause of a query statement. So what fields do you want to actually retrieve and display? And this can make sense because your JSON documents can get quite large, or they'll have data that you don't necessarily want to show. So for example, let's say you have a user document. In the user document, you may need to store a password, right? Or ideally, a salted hash of a password, because that is good security. But you almost never need to retrieve, actually, not almost. You should never need to retrieve that, right? So in your projections, you should always just not include the password field, right? This kind of thing. Also, just a quick note on that example. If you're building your own authentication system, stop. You should use something that's already been built, that is already security tested, all that kind of stuff, because you're not going to do a good job of it. If you were, you probably would not be in this class. I also don't try to build that kind of stuff because it is not safe and a good idea to do. Rely on other people who have spent a lot more time doing that. But yeah, any questions about the find query? Again, we're going to do demonstrations in a bit, but conceptually, any questions? Great. And then insert, update, delete. Insert is insert. You say insert, and then you give it a JSON document. Done. There are a couple of operations you can do, like you can do like date operations like now, or you can do like kind of calculations if you need to do like a derived value or something. But that's also quite simple. Update gets a little bit more complicated. An update is actually a find operation because you have to figure out which records you want to update because you don't want to update the whole collection. And then update has its own set of operators, right? So let's say there's an array as part of the document. You only want to update certain items in the array, or you only want to work, or maybe you want to do some kind of operation for each item in the array, because the array might not just be an array of strings. It could be an array of more JSON objects, right? So things can get a little bit complicated, but the update operators help you manage this complication. Okay, and again, we're not going to go over it in a lot of detail because this is just introductory. It's much easier to look this way. So, like the update operators are things like, okay, so show me documents where item is paper, and then set the value of the size key, which then has a sub-object, has another JSON object, and then in that other JSON object has a UOM key, and then set that value to CM. And then set the status key's value to P, right? And then set, I don't remember that one. And then for the last modified field, set it to the current date, right? This is a very nice, simple example of an update operation. $set is probably what you'll do most often because that's how you change values normally. But it has other operations for when you need to do dynamic things, again, like setting dates, or maybe setting the current user, or doing some sort of calculations, or doing a derived field, this kind of stuff. Additionally, I didn't actually write that in here. Updates also support pipelines. We're going to talk about pipelines more in a minute, but if you have a lot of complex operations you need to do to figure out what value you want to update the document with, like maybe you need to do like, find some other documents and split them and then merge them and do some calculation and all that. And then as a result of that, you need to set some value. You can do that using update pipelines. But that's more advanced. We're not going to get into that today. One thing to be aware of with MongoDB, duplicating your data is okay. Not only is it okay, it is encouraged. Okay? Now, for you people experienced in SQL, you might be like, heresy. We don't duplicate data. This is a database, right? But remember, disk is cheap. Indexes make you go fast. Memory, not so cheap, right? So if you can duplicate your data on disk a bunch of times, and then you don't have to load a bunch of virtual tables in memory from a bunch of joins, that's going to be faster, okay? Because you have to read from disk at some point anyway. That's what a database does. It stores data to disk. Well, it doesn't have to, but most databases require durability, so they store data to disk. But it is better to duplicate data among different documents than to join documents. MongoDB has an operator called lookup. If you're using lookup, you messed up. If you're using lookup, your data model is bad. Generally, like 99% of the time, okay? Instead, if you need data from one document and you need it in another document, you just copy the data. For example, let's say we're doing an event management system, like the example we used earlier. For an event, you'll have something like the title, you may have some image, you may have a description of the event, the time, the location, all these kinds of things, right? And then you'll also have maybe the host of the event and the people attending the event, right? Now maybe you have a separate user collection or member collection or whatever, a collection of people, right? And you might think in a SQL world, you would have an event table and a people table, and you'd have the event table reference the people table for the host, and then you might have like a many-to-many relationship for the attendees, right? That would be normal, good SQL design. But in MongoDB, no. You copy the host document, or the people document of the host, into the event document. Okay? You copy the attendees into the event document if it's a smaller event. Like if you have like 1,000 attendees, no, you want to use a different data model, right? And this, again, this is where your access patterns come in, right? Because if you don't know how you're going to access the data and you don't know what your data volume is, you're going to end up having a document with an array of like thousands of people, and then your performance is going to go to shit and you're going to wonder why. Okay? So again, know your access pattern first. So you would copy the people's data into the event document because you don't want to join. You want the document has all the data I need, and I don't need to do any extra work. Okay? So you just go, show me events where the title is Introduction to MongoDB. Find one document, grab, done. It has all the information you need. You don't need to do any lookups. You don't need to do any derivations. Everything is good. Okay? We're going to talk about this in more detail in the data modeling section because that's honestly the most important part. And I need to make sure I allocate time to that. But that's a big thing that you're just going to have to get comfortable with. You're going to have to duplicate data. It's a good thing. If you're coming from a SQL world, it's really uncomfortable. I was really uncomfortable with it for like 6 months until I finally accepted it. And then when I did start duplicating data, stuff got way easier. But duplicating data does have another cost. Let's say you have data duplicated in many different documents. What if you update that data? Then you have to go update all those different documents, right? That's another advantage of SQL systems, right? If you update it in one place, everything just references that one place, and so you don't have to go update it in many places. But in MongoDB, because you're duplicating, you have to update it in many places. And again, this is when I talked earlier about MongoDB is good, especially good for systems where you write once and read many times, where you don't have a lot of updates. Mongo's super easy and super great for that. But if you need to do updates, you need to make sure that you update all the different copies, okay? And that's extra effort, but for certain applications, it's worth it because MongoDB gives you other advantages like scalability, redundancy, all these kinds of things, okay? Does that make sense? Cool. And because of this data duplication, writes tend to be a little bit complicated, right? Or at least updates tend to be complicated because you have to update many records. You have to make sure, okay, if I update a people document, which other documents are using people? So you better have good documentation or good comments or something. And then lastly, the delete operation. Delete is delete. You just give it like a find query and it goes and deletes the records that match the find. Done. Okay? So any questions about this part? Yes?
So let's say I've made so many copies.
Yeah.
If I look for a given file and I want to delete it, what happens to the other copies?
Nothing.
They stay there.
They stay there. There's no references here. This is not a relational database, sir. So the question was, if I delete a document that has many copies, what happens? Nothing. Because in MongoDB, you don't want relationships, right? The whole point is that the document has all the data you need. You get that document, you're done, okay? If it has to do all this integrity checking, that's going to slow MongoDB down, right? MongoDB is meant to be fast, like single-digit milliseconds. Get that data out, right? If you have to do a bunch of integrity checks, if you have to do a whole bunch of references, if you have to search around on disk, it's not fast, right? Your find should have an index, which we'll talk about in a bit. It should have an index, find it in the index in log n time, grab the document, send the document, done. 7 milliseconds or something. Depends on a whole bunch of stuff, but yeah. Okay, does that make sense? You do an update, and then you go delete that sub document in the parent documents. Yep. What's up?
Provide consistency when we would like to update many documents at the same time. Does MongoDB support transactions, something like that?
Yes. So the question was, if you do need to update many documents, how do you ensure consistency? Yeah, I was just repeating it for the stream. Does MongoDB support transactions? Yes. Yes, it does. Now, you do want to ask yourself, do I actually need a transaction? Right? It depends on your use case. It depends on your data model, all this kind of stuff. Because transactions do occur cost, because you have to write all your changes in memory, and you have to wait for all the changes to happen before it can be completed and all that. Now, if it's okay if your writes take long, then yeah, whatever, use a transaction. And honestly, in my personal experience, in most applications, if writes take a little bit of time, that's fine. Usually people expect reads to be really fast from kind of a user experience thing, in my personal experience. But again, it depends on your use case. Maybe it's okay if it's not in a transaction. But again, consider the use case, consider the implications, consider the risks, all that kind of stuff. Does that answer your question? Great. Other questions? Yes?
You said we usually don't use transactions.
Hmm.
But normally, multiple people could work on the same data at the same time, right?
Mm.
So could it then not destroy this data somehow?
So the question was, let me fix this real quick.
Track what's the current version, right?
Yeah, so the question was, how do you handle when people are updating the same document at the same time? How do you make sure that you have a consistent version? So very early on in MongoDB's development, they didn't actually have a good way to handle that. And I was like, no, I'll never use MongoDB because that's super important, right? And then like they fix it in the next version or whatever. So generally, individual operations are atomic. But when it comes to transactions, it's the same as a SQL database, right? When you do a transaction, things get locked. Yeah. So again, the same as a SQL transaction. So if you end up doing like an operation that updates many records of a table in a SQL, it's been a long time and I'm not sure if my memory is good. I might be wrong about this, but if I recall correctly, if you're doing like a SQL update, and it's on a sufficient number of records, it might lock the whole table, or at least a portion of the table, and make those records untouchable until the update operation is finished, right? If you do a transaction in MongoDB, if I recall correctly, it works the same. It'll lock those. Yes, it does, because we ran into deadlock issues in MongoDB. Sorry, it's been a little bit since I've done it hands-on. But yeah, so that works the same between SQL and MongoDB. Does that answer your question? Cool. Other questions? Cool. Now there are things you can do with eventual consistency to kind of make that work, or to make that work faster and to reduce the risk without having transactions, if I remember. It's been a long time, and that's a more advanced thing that we didn't really need to use because we didn't need to do sharding and all that. But there are eventual consistency configurations you can do for MongoDB to avoid transactions while still having consistency. But it's been a while. I would need to read up on it. So if you need that, you can read up on it. Sound good? Cool. All right, any others before we go forward? Great. All right, gonna need to move a little bit faster because we're getting tight on time now. And then pipelines. Again, pipelines are multi-stage operations. They're primarily used for aggregations. So you might have like, so a pipeline is literally, again, everything is JSON, right? So a pipeline is literally a JSON array of JSON objects where each object is a step in the pipeline. So you'll often start a pipeline with a match operation, which is basically a find. And then you might have like a group, and then you might have a split, and then you might have like a bucket, and then you might have like an extract field, and you basically have a whole bunch of steps that it does in sequence to work with the data for whatever you're doing. Again, pipelines can be used for finds or for updates. So you can use it to kind of calculate what data needs to be updated with, or to find data. And it can get really complicated, but honestly, it's kind of fun, or at least I find it fun. Maybe I just hate myself. I don't know. But it does support more complicated operations like bucketing, like window functions, this kind of stuff. I already mentioned it's used in find and update. And the pipeline reference here. Yeah, so this is a very simple example. If you want to do so in SQL, you'll often have like a select count one from users group by city or something like that, right? If you want to count the number of users in each city. In MongoDB, you would need to use an aggregation pipeline. So you would say, aggregate on the orders collection. The first step is a match, which is basically a find, right? For any, I guess this is doing pizza orders. For any pizza where the size is medium, that will collect any documents where the size is set to medium. And then you have the group by statement, and you say, okay, I want to, I want to have each group be unique by name. And then I want to store the sum of the quantity field as total quantity in my output. Okay? So the output of this would be a JSON document with whatever the value of the name field is as kind of the group by field, and then stored as _ID, and then the total quantity as the sum of the quantity of each order. Do they have? Yeah, so basically like this. So if the name of the pizzas in the order is cheese, then the total quantity will be 50, right? This kind of stuff. Does that make sense? It's quite simple. It's a little bit different way of thinking, but if you can kind of forget about SQL for a second, it actually ends up being pretty simple to understand. If you don't know SQL, this is way easier to learn. If you know SQL, it gets a little bit tough. But does anyone have any questions about how you get from here to this kind of output? I realize there's one thing I did not make clear. When you see, so like this is just a normal string value, okay? But this is the name key from the documents that have been retrieved for the pipeline. So if we look at here, we have name cheese, right? So if they do $name here, the value cheese is going to be substituted here. It works like a variable, basically, okay? And the thing that's a little bit confusing is that the MongoDB operator functions start with a $, and you reference the document keys with a $. I kind of hate that because it's a little ambiguous, but that's how it works. And you do get used to it because you end up memorizing the operators over time anyway. So, I mean, it kind of is. It's a reference, right? I mean, it's not exactly a pointer, but yeah. So any questions about this one? Great. So I do recommend playing with pipelines because they are kind of fun. You can do like silly stuff that like would be way more difficult to do in SQL. And then there's other stuff where you're like, this is so easy to do in SQL, why is it so hard in a pipeline? So it's kind of fun to see what the differences are. But back to this. So, yeah, okay. And then, so we talked a lot about like how MongoDB is different, but what is the same between MongoDB and SQL databases? So first off, indexes. You still have indexing in MongoDB. You can do single value indexes. You can do compound indexes, just like in SQL databases. Some stuff that's interesting is if you have your JSON document which has nested JSON objects, you can index on the nested values, however many deep. Doesn't matter, okay? Additionally, if you have an array, you can index the array values in the document. which like makes total sense, but is also really cool. So for example, let's say you have, let's go back to the events example. And let's say you start labeling your events, and each event has like 5 or 6 labels or whatever. And you're like, I want to find any event with the label databases, right? You can just index that labels field, and it'll index all the values of the array, and it'll retrieve just like a normal index query. Okay. And then transactions, we talked about that earlier. Transactions do get slightly complicated when you introduce sharding and replication because of the eventual consistency stuff I mentioned earlier, but they largely work the same otherwise. And that's pretty much it. Everything else is quite different, or at least that I could think of in the short time I had to prepare things. So any questions about other stuff that you feel might be similar but you're not sure between SQL databases and MongoDB, or are you okay? Great. So, I just realized I'm not using my tools properly here. Give me a second. Okay, that's much easier. So, who's ready to actually like write some code? If you want to follow along, you can go to this GitHub repository. I will also share it in the, oh, right. It's over here. I will also share it in the Discord, if that is easier for you. Why are you over here? You were over there earlier. All right, anyway. There is the repository. It is a very basic repository, again, because my time was limited. But if you have all the prerequisites sorted out like I described earlier, it should be no problem to run this. Okay, so I'll give who all is following along? One. All right. I'm going to go a little bit fast. If you need me to slow down, let me know. Okay. So once you've cloned that down, you can do kind of normal project setup. You do npm install, right? Because this is JavaScript land. Now, to be clear, you can use MongoDB with whatever language. There are clients in all of the, maybe not all of the languages, but you know, all of the major languages. And then I'm going to go ahead and bring up my MongoDB here. All right, it's already up. In this repository, I defined a Docker Compose file, which sets up a MongoDB container for you. So you can just do Docker Compose up-d to run it in the background. And it'll be configured with the username is root and the password is root. When you clone this down, best practices, your env files should not be in Git. So I made this template. You can just copy the template to the env file because this is only for the local database, right? But if you end up using this as kind of like a boilerplate for a MongoDB application that you build, I don't want you like accidentally committing your env file. So that's why I did it this way. And then the application is very simple. We're not actually working with any data here yet. You can just do npm start. God, I hate JavaScript. And it connects to the database and then says done, okay? Because I didn't have a chance to prepare a bunch of stuff in advance, so we're gonna do it live, because what could possibly go wrong? Yeah. So, does this make sense so far? Okay, in terms of the code that's actually here, MongoDB is just another NPM dependency. There's also like Mongo Python in Python world. There's also like a MongoDB client for Golang, whatever. And you construct your connection string, just like many other database clients. There might be a way to do it as an object instead, but it's been a long time since I've done this, and I was doing it in a hurry. I had some example code that used a connection string, so I just used a connection string. But should check if there's like an object way to do it, because that's more readable. And then you just, you create your client as usual, and then in your application you just connect. It is asynchronous. Okay, so if you're doing JavaScript things, you should be comfortable with async, but I'm hoping that if you're in a class like this, you're already comfortable with that. And then we can do stuff. So, I'm sorry guys, I messed up. In the MongoDB structure slide, there was like cluster, shard, replica, instance collection document. I forgot a layer. I'm sorry. I'll update the slides. You also have a database, okay, which is above a collection. If you're familiar with SQL, a database in MongoDB is just like a Postgres database, okay? But it is not like a MySQL schema because you cannot join across databases, okay? In MySQL, you can join across schemas. In MongoDB, if you do lookups, which you shouldn't be doing, but if you need to do lookups for whatever reason, you cannot do lookups across databases in MongoDB, okay? So you can create a DB to kind of segment your data. It's like an isolated schema. And then you can create a collection, and a collection is roughly equivalent to a table, okay? A collection should store documents of a similar-ish format and similar purpose, okay? All good? All right, so now what we can do, we're going to see how good my memory is, okay? So for our collection object, right, I'm going to insert one. Actually, let's insert many. Let's insert an array of documents. Autocomplete is like the best thing ever. And that gives me enough information to run with. Also, we need to await this. There we go. And let's also go ahead and const result this, even though it's an insert. You'll see why in a second, because there's just, normal logistical stuff we should cover. Okay, so I can say employees, we're going to say, this is JSON or JavaScript, so I don't need to do that. We can say name Beege. We can do, yeah, let's do that one. And then we can do like, title is team lead or whatever. And then we can do, I don't know, joined on, oh crap. That was a bad choice because now my bad memory is showing. I think there's something like this. But we're going to see if that works. Let's see. I don't think it will, but we're going to try it. I'm pretty sure that's actually not going to work, but let's go with it. And then we can do like, I'll just do another one of my coworkers. We'll do Andre. By the way, if you haven't gone to Free Code Camp, you should totally check it out. Andre runs Free Code Camp. They're a great group. His title is software engineer. And crap, I don't remember when he joined the company, so I'm just going to make something up. I'm pretty sure he joined that same year. And I'm just going to make up a date. I guarantee you that's wrong. Andre's going to shame me for this if he sees it, but that's okay. He's going to be like, I thought you were my friend. You should know this. Yeah, so this is, again, insert is insert. Very basic, very simple. Right? So far, so good? Cool. And then, how do I want to do this? Do you guys want to gamble today? How risky are we feeling? I am sleep deprived, so my judgment is poor. I'm going to gamble. I'm not going to test this, and we're going to see how it goes. It's going to be great. We might have to blow up the database a few times to get it right, but it's going to be fine. What could possibly go wrong? And then, with our result object, we can do something like we have insert account, so we can double check to see how many got inserted. We can get the IDs of the documents that were inserted. Super, super useful, especially if you're doing API stuff, because you want to show like, the ID of the document that got inserted so that you can do other operations with it. And I believe that's a function, right? It is, let me double check here. It is, no, it's just property. And let's do something fancy like inserted IDs. And, oh my God, I don't remember JavaScript. Okay, cool. Great. And then, Andre and I, we are in certain teams, right? So maybe, also let me rename this because I swear Once upon a time, I was a software engineer. And we should not use generic names for things. We're going to create another collection called teams. And we're going to do something like this, just as you would expect, right? And then we can go ahead and, oh, this should not be const. This should instead be let. I swear I know JavaScript. And then we can say result equals, wait teams dot insert many. Insert many. I'm sorry that you're watching me type, guys. I did not have enough time to prepare. So we can say something like product management, and we can say something like front-end engineering. Okay, great. So any surprises here? That all seems fine, right? Something worth noting. In SQL, right? When you create a table, you must explicitly define an ID field, right? You can name it whatever you want. It can be whatever data type you want. And technically, you don't even need one. But usually, you must define a primary key, right? Usually, it's either an integer or a UUID or something like that, right? In MongoDB, you do not get a choice. Well, actually, no, that's not true. You can change it. You can change it. But by default, every document in MongoDB has an underscore ID field, and it generates what's called an object ID. It's a BSON data type. It's basically a hash. Okay, so it's a hexadecimal value, right? So 0 through 9, A through F. And you don't have to worry about ID management. MongoDB does it for you. I love it. But, for some reason, maybe you don't want to do things that way. Maybe you're doing like time series stuff, and that doesn't work for you, but yeah. So we don't need to worry about IDs here, so don't panic about that. But I have a question for you. Employees belong to teams, right? Now, given what I've told you about how we should do data in MongoDB, how do you think we should model the relationship between employees and teams? You're like,
Duplicate and then remove certain members from certain.
So the answer was maybe duplicate and remove certain members from certain teams. Yes, possibly. Other options? There's a very specific answer I'm looking for. A very specific answer that I emphasized multiple times. And the answer should be in the form of a question. Who can figure it out? Yes! What is our access pattern? I should not decide how to model the data until I know how I'm going to use the data. Okay? So the question is, if I'm querying these two collections, okay, am I more concerned about seeing which employees belong to a team, or more concerned about which team an employee belongs to? Or am I concerned about both? This is an important question because it determines, do I embed the team into the employee, or do I embed the employees into the team? And then also, how big can the team be? If a team can be 1,000 people, then I don't want to embed the employees into the team. The document would get too big. Okay? So this is why thinking through your access patterns, how you're going to use the data, what is the nature of the data, is very important if you're going to use MongoDB. If you do not, I know I'm repeating myself, but it's important, you need to remember it. If you do not consider how you will access and use the data before you design your MongoDB data model, you will hate yourself, okay? Know your access pattern. Now, just for purposes of demonstration, because this part is not as focused on data modeling, I'm just going to make an assumption here, which you should not do, but we don't have an actual application we're demonstrating. I'm going to embed the teams into the employees because I'm more interested in seeing what team an employee is a member of rather than seeing the team composition, okay? So I'm gonna move some stuff around here. Ah, crap. Nah, I'm gonna have to change a bunch of stuff. Maybe not a bunch of stuff, but you get the idea. And then let's get this guy up here as well. And then now you're gonna see why stuff is I don't remember something. Shit. How much time do we got? Okay, so in SQL, when you do an insert, right, you can just insert the data raw, or you can insert the data as a select query, right? So you can say, you know, select, and then maybe this field is fixed, but maybe this other data I need to go retrieve from another table, right? Especially in the case where you're finding references and you need to insert an ID for like a many-to-one relationship, right? I'm quite confident MongoDB can do that too, but it's been a long time and I did not have enough time to prepare, and I don't remember how. So I'm going to do it the stupid way, and I apologize, but we don't have enough time for me to go figure out the right way, and I did not have enough time to prepare, and I apologize, but I'm quite confident you can do that kind of thing in MongoDB. I just don't remember how at this moment. So what I'm going to do is a terrible thing, and I'm going to do not do it this way in a real application, okay? I'm going to do something like this just to show you the proper way to embed another document. I'm going to do team, and I'm going to give ID, and I'm going to get the results dot inserted IDs 0. This is not good. Don't do this. Don't do this. I'm so sorry. I feel really bad now. And then the team name as, you know, product management. Again, I'm quite confident there is a way to do this properly where you can go retrieve it as part of the insert. I just don't remember how. I'm sorry, guys. And then we'll do this. Yeah, I'm sorry. We don't have a lot of outlets in here. It sucks, but yeah. And then we'll do the same over here, where I will do this. Again, do not do this in a real application. This is not the proper way to do it, but we don't have a lot of time because I want to spend a lot more time on the data modeling. This is absolutely not a smart way to do it. But this is how you would do this kind of embedding if you are more concerned about seeing what team a member belongs to. Okay? And now we're going to try it, and we're going to hope that it works. I'm pretty sure it won't, but we're going to try it. I'm pretty sure this is wrong. But let's see what happens. It's going to be great. I need to... Hey, it worked! Oh God, what does that mean? You guys have seen that meme of like, oh, my code doesn't work. I wonder why. My code works. Oh God, why? But now we're going to do... I recommended that you guys install MongoDB Compass. I'm going to show you guys how to use this one briefly. Yeah, I'm going to add a new connection, localhost 27017, because that's how I configured my Docker Compose. I'm going to call it localhost. That's fine. Yeah, the authentication is root. I don't know why that's under advanced. I don't know, whatever. You can leave that out, that's fine. And then you can hit go. Oh, great, it worked. Whew, okay. So here is my HR database that we created in our application. You can see the employees' documents, you can see the team's documents. And then, yeah, it didn't work. Yeah, oops, whatever. But yeah, you can see the ID was automatically generated. We were able to fetch the ID from the previous insert and embed it like this, okay? So you've seen how to insert data, okay? Cool, but how do we retrieve data? Now, I could write the code to do it, right? But I'm just going to do it here in MongoDB Compass so you can see how. And it's quite easy to imagine it as code. You just take this one, make it as the first parameter, take the other one, take it as the second parameter, you're done. But I'm going to show you real quick. And we're right on time. Cool. So in this case, this bar up here is basically a find query. Okay. So if I want to find the members of the product management team, what I can do is I can say, I forget if I need quotes if we need a dot. So we're going to try it. We can do team.name. Oh yeah, here we go. Is it going to? Yeah, it's going to force quotes. So if you don't have, if it's not a nested field, you don't need the quotes. If it is a nested field, you do a dot to indicate that you're going to a sub-object, and you need to have quotes, okay? And then we can say product management, and then we can find, and there we go. No, go away. I don't need your marketing nonsense. And so there we go. We were able to filter for that one record, okay? So does that make sense for the find so far? All right. If I were to do this in here, all it would be is employees.find, and then this. That's it. And you know, you would need to do like results equals awaits, right? This kind of thing. But same operation, same exact thing. Okay? Make sense? Cool. Now let's say that I don't care about these IDs. Okay? When I'm showing this data to the user, I don't need the ID. The front end doesn't need the UID, or doesn't need the ID for whatever reason, right? And maybe I only care about the name of the team member and the name of the team. Okay? How do I do that? Earlier, I described to you guys projections. Okay? So what we can do is we can click options here. I don't know why it's hidden behind this options field, but whatever. And we can say project. Okay? We can say name. And you can just do 1. And that'll tell MongoDB, like, just use this field, and whatever the value is, just use the value. Okay? And then maybe I want to have the team name as a key, just team. So what I can do is I can say team is $team.name. Okay? There we go. But you're like, but Beege, I thought we didn't care about the ID, right? By default, MongoDB will always include the ID, okay? Because normally you need it. So MongoDB's like, I got you. I know you want this. I'm just going to give it to you, right? Because that's the more common use case. The more common use case is you need the ID. I'm like blocking the camera with my arm, whatever. You don't need to see my ugly mug anyway. But if you want to get rid of the ID for whatever reason, you can do this. -1 says, I believe it says don't show it. We're going to find out. Nope. Okay. Maybe I'm wrong. It's been a long time. Oh, sorry. It's not -1. It's 0. I don't like using numbers to denote this stuff. I think that's bad design, but whatever. Maybe there is another way to do it, and I just don't know about it. It's been a long time. I'm sorry, guys. Yeah. So if you do like ID 0, then the ID is removed. Okay? So that's a projection. Make sense? And then if we were to do this in code, by default, I believe in all the implementations of the MongoDB client, the projection is the... I'm wrong. So you do something like this, find options, and we set projection as, then you do your object, okay? So it would look like this if I were to format this properly. Oh my God, I am so bad at writing code. I swear once upon a time I was a software engineer, okay? So your first parameter is your find. Your second parameter is the options for the query, and we set the projection option to this. Okay? Does that make sense? Questions about this so far? Cool. And then the last example we'll do before we get into the data modeling is what if I want to do an aggregation pipeline? Okay? The nice part is that Compass is really nice for experimenting with aggregations because it gives you previews of the documents at each step of the aggregation pipeline. Ah, that's good design. So it's been so long. So we're going to add a stage. Our first stage is going to be a match. Match is basically like a find. Okay. So I'm going to say well, I want both records. We only have 2 records to work with. Well, it's not an actual date field because I'm dumb and didn't remember how to do it. I'm just going to do something stupid. I'm going to do exists name 1, I think. It's been a long time. What's wrong? Oh yeah, I should do proper BSON. Nope. Okay. I got it backwards. Sorry. Name exists 1. There we go. So this exists operator just checks to see if that key is in the document. Okay, so if the name key is in the document, this will evaluate to true. Make sense? Cool. So there's a completely bullshit match query, but it's fine. What was that? Yeah. And then let's say I want to see the number of employees in each team, right? Now, if we were in SQL, what we would need to do is we would need to query employees. We would need to join to teams, and then we need to group by the team name or whatever, right? But in MongoDB, because we've embedded the team info into the employee document, we just need the employee document. It gets way easier. And then if we've added an index, I didn't show you guys indexes. I'll show it to you in a minute. If there's an index, it'll just use the index to do the query, and then it doesn't even actually hit the documents themselves. It just hits the index, and you get like super fast, fun stuff. So we can do group, and then I love that. It pre-populates it for you. Oh, they designed this part super well. I'm super happy with it. And then we can say, team.name. And then we can say count members as count. And we can just say ID. Oh, okay. Sorry, it's been a long time. Oh, excellent tooltip. Oh, okay. Does that make sense? Are you having trouble? Okay. And then, again, you can see a preview. Okay. So here we go. You can see that the ID is the name of each team, and then the count of members is just 1. Okay, pretty simple, very similar to the example we did earlier. I want to show another example, but there's not a lot of time. There's a lot of examples and documentation around pipelines because people tend to have a lot of trouble with them. So if you're doing pipelines, there's plenty of help online, or if you can always come to our Discord and ask for help. And I love MongoDB pipelines, so if you need a hand, I can help you out. But yeah, and then the way this would work in the nice part about MongoDB Compass 2 is because they expect you to use this to help you write the pipelines, you can just say export to language. Because we're using JavaScript, we can just use the native version, but you can convert it to Python, you can convert it to, Node. Okay, there we go. So I can just say, that's interesting. Oh, because of the $sign. So I can just, copy this, and I can do employees.aggregate and paste. Done. Okay? And then I can run my query. Now, I'm going to get duplicate data because I didn't clean out the database. But basically, also we should do let me log this stuff out. So let's say find results. And then let's do this. My formatting is bad, but whatever, it's fine. Pipeline results. Okay. All right, let's see if this works. Ah, what? What do you mean results is not defined? We did it right up here. Oh. Fine, be that way. Okay, so I'm gonna have a bunch of duplicate data. It's fine. It's fine. Oh, yeah, my log. Sorry guys, I suck. I should have just done like a find replace or something. Right, right. Okay. There we go. Oh. Right. Right. NodeJS. Okay, we're gonna do something stupid. I'm sorry. Maybe I'm not a software engineer anymore, which really hurts to say, but it's okay. It's okay. There we go. Okay. So gross. Right, I forgot that it's actually a bunch of junk. Let's clean that up. Sorry guys, it's been a long time. Okay, I only got 3 minutes to get this done. What? Crap. Okay, so we're gonna revert that. I'm so sorry, guys. Now, give me my proper... Oh, come on. Really? Crap. Alright, we're just going to do this then. Find cursor. Clone, explain, filter, hint, min, max. What? This is not what I'm looking for. Shit. Check, sort, collation, skip. Damn it. I'm sorry, guys. It's been too long and I didn't have a chance to test this. Crap. Aha. Nope. Maybe this? No, because that's just doing... I shouldn't be looking up documentation during a workshop. Just give me the damn... Yeah, I understand you're returning it. Right, because it's the MongoDB client. There we go. What? Yeah, okay, good enough. Huh? Oh, because that's a find one. I want to find many. There we go. Oh, really? That's annoying as shit, but okay, let's try that. Because I really want to show you guys this this result output, but we're gonna see how this goes. But then wasn't that... Wait, yeah, it's not an insert many results anymore. Why are you complaining? I already changed it. Oh, because I didn't change it. Oh, and I'm out of time. Shit. So that would be why the autocomplete wasn't working. There we go. Read? No? To array? To array. Yeah, okay, so that was right. Okay. And then, is this a... That's a promise. So, and then what does this return? Yeah, it just returns a cursor, so we actually need to do this. Okay. Okay, here we go. Here we go. Alright. Okay, okay. Let's try it again. Spectacular. Okay, I'm sorry that took so much effort, guys. But yeah, basically that's just demonstrating what we did in code. Because I ran it so many times, we have a bunch of duplicate data. Because This is shit engineering, but it's fine. Any questions about this absolute nonsense? Yes.
So there's really no concept of foreign keys and
Correct.
it's all just printing some strings inside my JSON to connect these relationships.
Yes. So the question was, there's no concept of foreign keys. It's really just strings and data to do relationships. Yes.
And I, as a programmer, have to handle every of this.
Yep. And so you have to handle everything yourself. Now, the nice part, at least, is these IDs are not, they're not just strings. So the efficiency is a little bit better. It's a BSON object ID, so that's much faster. And also it guarantees uniqueness and all that kind of stuff. So that makes it a little bit easier, especially since every document has it by default. But again, you have to like copy the ID to each document and all that kind of stuff. But again, maybe you don't need the ID in certain cases.
So this ID is a reference to the other document?
It is, but it's not. It is a reference to the other document, but it is not enforced. Right? So a foreign key in SQL databases usually has some kind of data integrity checks, right? MongoDB does not. Good question. Any other questions? All right, so now to the actual important part. We have 17 minutes left. And I'm going to clean this up a little bit, and I'm going to update that GitHub repository with this version. I'll maybe add a couple more examples as well, and I'll add comments and all that kind of stuff, and that way you can have a nice example to work with and reference for the code layer of things, okay? So, and I'll commit what I have now. It's a bit embarrassing, but I'll just commit what I have now. Examples from in workshop. Embarrassing. God, I hope no potential employer ever sees that commit. Okay, anyway. Back to this. So, moving on to the data modeling side of things. Why did I... Yeah, okay. So again, I know I keep repeating it, but it's super important. Know your access patterns first. Otherwise, your data modeling is going to be wrong. Your code is going to be a pain in the ass to write, and you're going to hate life. We want to be happy, right? Again, duplication is okay. All right? And then embedding documents. We just went over an example of embedding documents. Okay? But I want to talk a little bit more in detail about embedding documents. Okay? Earlier I mentioned you'll have cases where you have an array of embedded documents, right? So going back to the events example, you might have an event with some number of members who have RSVP'd, and so you can embed those member documents into you can embed the member documents into the event document in like an RSVPs array, right? That's a perfectly fine design if you know your number of RSVPs will be small, okay? But when I say that, hopefully the more critically minded of you are thinking, okay, Beege, what is small? Okay? You should double check this, but as I recall, MongoDB documents are limited to 16 megabytes. Okay? One document cannot be larger than 16 megabytes, which, again, I may not be remembering that 100% correct. You should check it. And honestly, I think that's way too big. But that is a hard constraint. Okay? And honestly, if you have an individual document getting to 16 megabytes, you're doing something super wrong. But that's, when we're talking about large, that's what we're thinking of. So if you're embedding like thousands of documents, no. I would also say even hundreds of documents is probably not good. Okay? Dozens could be okay depending on the use case. Because also remember, when you do embed documents, right, you have projections. Okay? Because maybe, let's say you have a user document, and maybe let's say they have their event attendance history, right? and maybe you don't expect, maybe it's like a once a year event. And so, or the tool is only for events that happen once a year. So then you're like, okay, I can embed the events in the user because it's going to grow at 1 per year, and it's not like this company's going to be around for like 100 years, right? Or at least, maybe hope not. Who knows? Whatever. Crap! I forgot where I was going with that.
Size of
Yeah, size of the document. Right. And when you have this user document, right, that will be useful if you go to the user profile page, right, and you want to see all the events they've been to, right? But on the user list page or the user search page or whatever, you're not going to want to see every single event they've went to on that page. That's too much information. That would be a bad user experience, a bad UI design, right? So don't forget to use your projections, right? So you can filter out the event list, right? Now, this is where the access patterns versus your data modeling becomes a little bit more of an art, right? Because, you don't want, there may be times where you may want 2 different employee or member or whatever collections, right? One with certain information, one without certain information, right? There are times where you want to do that. It's a little bit rare, but there are times where you want to do that. But then you figure, okay, what if I have it all in one document, but then I do projections to filter certain things in and out, right? So you have to kind of figure out which is the better way to do things. And then another thing with embedding documents is when we were going over the employees and teams example, right? You could do it in 2 directions. Right, you can embed the members into the team, and you can embed the team into the members, right? Doing this 2-way kind of thing is totally okay, right? You can do that, that's no problem. But again, you need to know your access pattern. But don't forget, when you're designing this stuff, you're incurring write overhead. Because if the team name changes, you need to go update all the members, right? Or if an employee, in the West, we have in many Western cultures, there's the tradition where if a woman gets married, she may take the husband's last name. So if an employee's name changes and you embed the employees in the teams, you may have to go change references to that employee's name if they get married or something, right? Now, in the case of the employee getting married, that one's a little bit easy because you're only updating one record, right? But in the case of updating a team name, you have to go update it in every employee record. Now, fortunately, both of those cases only end up being a single update query, so it's not a huge deal. But again, you have to keep track of which other collections have I embedded these documents in, okay? So remember that. What's up? I'm sorry? Some notifications popping up? Oh, sorry, I should turn that off. Oops. Let me just do this. Nope, okay. Thank you for the heads up. I always forget to turn it off. Thank you. Okay. I hope it was nothing embarrassing. It'll be on the internet, so I kind of want to open it now, but yeah, let's continue. Now I'm really nervous because, I can't edit this video. Moving on. This is why you should plan things, boys and girls, and take time with stuff, because some stuff is irreversible. And then I want to go over design patterns. So MongoDB has this thing called MongoDB University. And if you're going to do work in MongoDB, if you're going to do data modeling, absolutely go through at least some of the videos in MongoDB University. Also, they are excellent. Normally, I hate learning through videos. It is too slow for me. I read much faster. I would much rather read documentation than watch a video. Especially because, I'm a bit of a curmudgeon and sometimes people piss me off. But the MongoDB University videos are so well made. Most of them are quite short. I don't think any of them are more than 30 minutes. Most of them are 10 to 20 minutes. And the presenter is very clear. The pace is very good. It's spoken about in very common language. I believe the presenter is French, so his accent is a little bit difficult to understand now and then because it's a little bit thick, but it's still manageable. And it's just really, really well explained. They have excellent videos. Like, sometimes I look at my presentations and I'm like, I don't think I could be a presenter on MongoDB University. But I do recommend checking that out. They have these design patterns. They have general ideas about how to model things in MongoDB. We're going to go over a couple of these design patterns, but there's many more. But I'll just give you kind of a preview of the stuff that you'll learn if you go through that stuff, okay? So, except I accidentally closed the windows. So we're going to do it this way. Nope, there it is. I do have this additional resources page with links to everything that I referenced, along with this MongoDB design patterns and the general MongoDB University page. But for ease, we're just going to do this. And this is a blog post basically summarizing those videos. If you do prefer to read rather than the videos, I just saw the videos before I saw this, and the videos were bearable enough. And the ones I wanted to go over were the attribute pattern, the computed pattern, and the polymorphic pattern, and the subset pattern. Now, a lot of these patterns are good. I recommend at least reading once through each of them. They're not too long. The schema versioning pattern is also very useful for operation stuff. But it's useful, but it's kind of boring to me, so we're going to skip that. But the attribute pattern is basically a way to, this is all about how to structure your data in a way that is sensible and easy to use and performs well in MongoDB. That's what these design patterns are, okay? So let's take an example of movies, right? So movies will release at different dates across the world, right? And maybe you need to track all of these release dates if you're doing like a movie database. And so you might be tempted to say, hey, here's the release for the US, here's the release for France, here's the release for South Korea, right? All these different things. And each of those should be a different key, right? But basically what they say is, rather than have a whole bunch of different custom keys at kind of the top level, it is much better to split the key into its constituent attributes, okay? Because what if you need to filter on the release date? If you're going to filter on the release date, you want an index on it. You don't want to create an index for every country in the world, right? So instead, what they recommend in the attribute pattern is to take these kind of compound keys and split them into separate objects, right? So basically, this is constant, right? And this is variable, right? So let's split it like that. Let's make a releases key, which is consistent, and let's make a location key that is consistent, and then we take the variable part of it and make it the data, because the data should be variable, the keys should not, right? Now, when you see this, you're like, well, yeah, of course, that makes sense. But I guarantee you that if you hadn't seen this first, you might have done the first version, because I did that too. And even at our company now, our researchers kind of do that sometimes when they're designing non-MongoDB JSON schemas, right? But the wonderful thing about this is that even if you never use MongoDB, some of these design patterns are still useful. I actually took this design pattern, I sent it to our researchers, because in the JSON data that they were basically modeling, again, not to be in MongoDB, just for like actual JSON data being passed around between applications, they had dynamic keys. No, okay? Because dynamic JSON keys will increase the complexity of your code. It makes things way harder, right? So your keys should be consistent, should be stable, they should not change very often, okay? And this attribute pattern is one way of doing that, okay? So does that make sense for the attribute pattern? Cool. And then for the computed pattern, this is, again, MongoDB is all about super fast reads, right? Like very low millisecond count reads. So there are times where you might do a bunch of calculations, right? So for example, let's say it's an e-commerce website, and maybe you want to show the users how much money they spent in the past year. From a product perspective, that's actually a terrible idea because you don't want to show people how much money they've spent on stuff. That makes them not want to buy more. But just for purposes of argument, let's say you're doing e-commerce. You want to show how many won they've spent throughout the year. You don't want to. You could write a query to just go through all orders where they are the purchasing user and just sum all the order counts, right? You could do that. But if there's someone who buys something 2 or 3 times a day, maybe they work as part of some requisitioning service or company or something, right? That's going to take a bit, right? And so your read's going to end up taking longer because you're going to have to pull a bunch of different documents and you're going to have to do a bunch of aggregations and all this kind of stuff. So the computed pattern is basically, if you know in your access pattern, because you should be thinking about your access patterns before you model your data, if you know that you will need some kind of aggregated value, why not just recalculate the aggregation every time it changes? Then when you do your read, you don't have to do the aggregation again. You can just pull the already aggregated value. Okay? That is the computed pattern. Because again, MongoDB's goal is to be as fast as possible on read. Okay? And so, actually that's it. These patterns are very simple. But even these simple changes can be very effective in terms of performance. Okay? And we got 2 minutes left. Then there is the polymorphic pattern. This is kind of the flexible consistency bit we referenced earlier, where let's say that you have a collection of documents, but depending on the data in the documents, your keys might change a little bit, right? Well, the problem is we just talked about how you want keys to be consistent. So how do you manage this? Well, you kind of want to create a boundary, right, between the stable keys and the stable keys for a subset of the documents. Okay? So in this example, tennis and 10-pin bowling are very different sports, but you still might have a sports collection of documents, right? And you'll need to record different data for these two sports, right? Now, some data is consistent, right? Those green ones in this top one here, those are common regardless of the sport. But then some things are variable depending on the sport, right? So in those cases, you want to kind of section. I'm confused. Wait a second. Yeah. You want to kind of section stuff off so that your consistent data is kind of in one part. Your consistent fields are in one part of the document, and your inconsistent fields are in another part of the document. If I'm remembering this one properly. It's been a while. You should read the article. And then the last one we want to go over is the subset pattern. We kind of mentioned this earlier, where, maybe if we go back to the e-commerce example, maybe you want to show the user their most recent purchases, right? And rather than having to query the user data and then go query the order data, why not just embed the most recent 10 orders in the user data? And then whenever a user makes a new order, right, writes can be a little bit slow. Reads should be fast, right? So when we create a new order, also update the user document, remove the oldest order, add the new order to the beginning. Done. And now your read, you just pull the whole user, including the orders, done. Does that make sense? Cool. But also remember, you incur overhead. Because what if they cancel their order? Then you have to make sure you remember to go update it in the user document as well. Okay, so stuff gets pretty complex. You really need to understand your access patterns well. You should have them well documented. You should understand how the data interacts and works with each other. Okay? So, that is all the time we have. So, any final questions before we go get some food? There is no way I taught that this well on 3 hours of sleep. Yeah, what's up? There we go. Yeah, so the question was, are we uploading the video to YouTube again? actually, I don't need to repeat it because if it's on like the YouTube people know this already. So whenever I do a workshop, I stream it, and the stream is automatically recorded on YouTube. So I'm very nervous about what those notifications were. Yeah. Now, not all presenters in CodeSoul do that because it requires a bunch of setup, and maybe there wasn't enough time that day. We try to do it for every session, but not everyone has it. All the ones I do should have it, though. Yeah. Any other questions? Going once. Going twice. All right. Well, thank you, everyone. Today we covered, in a broad sense, what are NoSQL databases. Okay. Then we went into a little bit more detail about what is MongoDB. Kind of, is it scalable? Is it redundant? All these kinds of things. We talked about when should we use MongoDB? What are the good use cases for it, and what are maybe some less good use cases for it? We also talked about how do you use MongoDB in terms of like the structure of it, which I need to go fix later, along with how do queries work, what are the different operators you can use, and the ways that it's similar to SQL. And we did that little bit of demo, and we went over a little bit of the data modeling. Again, I do strongly recommend MongoDB University. It is great. Yeah. So good job, everyone, on capturing all of that and for listening to hopefully my not too annoying voice. In these slides are these references here so that you can find them if you need, or you can just do a Google search. They're easy enough to find. And if you do need if for some reason you find the slides but you don't find the YouTube video, you can do this. Thank you again for joining. This is the Discord channel again if you did not join earlier and decide you want to join now. My email is also on there, although I'm not great at checking it. I realize I haven't checked it in weeks. Yeah, going to check that now. Discord is much better, especially because I now learned about the direct messages queuing feature. So I'm sorry for those of you that have been waiting for messages for a while, but it should be better from now on. Also, CodeSoul is an actual legal organization. We are a nonprofit. I think we're a nonprofit sole proprietorship. We're trying to become a nonprofit corporation, but it's expensive and requires a lot of paperwork, so we're trying to figure that out. So we run on donations. Now, these donations, I don't make money from this. I actually lose a ton of money on this, but that's fine. It's fun. But if you would like to donate, donating money goes to help the cost of dinner, like we're going to do in a minute. But it is not required. Also, if you do not have income or you're a student, do not donate. If I learn you did, I will be very upset with you. Don't do it, because you need your money for other things. We're fine. But if you do want to offset the cost of food, it's cool. Also, to be clear, using this space does not cost us anything. Lunit is kind enough to grant us this for free. In exchange, we talk about Lunit all the time because it is a good company. I do like working here. I do recommend applying if you want to get in, although if you're doing machine learning, it's incredibly difficult, as some of you have already learned. I'm actually quite disappointed and upset about, but don't have much control over it. But yeah, and that covers everything. So thank you for everyone for coming, and we're gonna go to get some chicken, if everyone's okay with it, and hopefully we can find some non-chicken options for those people that chicken doesn't work for. And if you're watching online and are capable of joining in person, come get some chicken with us in the future. Next week is going to be a social where we just kind of come and hang out. So if you're in town for that, come join that. And then I believe the following week, we're currently planning to do an introduction to Rust. I had to finalize a couple of things on that, but we're going to have another Lunit employee give an introduction to Rust. He is very excited about it and spends way too much personal time on it. But that means he should be good at teaching you guys about it. So stay tuned for that. I'm hoping to get it posted sometime this week. And I've been talking enough. Let's go eat. Thank you, everyone. And how do I computer?